Hey guys, welcome to Code Decode. In this video, we are going to look into some Java 8 streams complex operations. This video is in continuation to the video that I have created previously on the operations we can perform on Java 8. Now going forward, these are some more even complex operations that you can perform on streams. Applying and understanding these operations are very important because when an interview asks you in real time that how would you solve this problem, understanding what all operations are available in your hands will be very helpful for implementing the solution to the problem given. So let's get started and see all possible operations which can be applied on streams apart from the one that I've already created previously. The link for that video will be given in the description below. Now let's get started. The operations that we will be covering mostly in this video is the partitioning by, grouping by, counting, summarizing, mapping, joining, filtering, collecting and then mapping, toMap, concurrent map, reducing and so much more. So let's get started and start this video. So how are we going to cover this? Okay, so we will be first covering the operation, then its description, then we will see how a simple question might look like and then its solution, and then after that we will also see the real-time use case for an e-commerce website, how you can use this operation if such an example is given to you in an interview. So real-time use case is also very important. Now let's get started. Let's start with partitioning by. So partitioning by is a method used to partition the elements into two groups based on the predicate. Too much of theory, we'll come back to theory once we understand how this actually works. So you are given a list of integers and we have to partition it in the even and odd numbers. So you can see you have a list given. Now you have to partition it based on some predicate. So partitioning is a method used to partition your given stream into two groups. That is a boolean, true and false, based on the predicate. So what is the return time of predicate? A predicate always returns you true or false. So based on that predicate, your whole list can be divided into two parts. For example, partition a list into even and odd numbers. So a boolean condition for that can be any number which is divisible by 2 is returns a 0 becomes an even number, otherwise it becomes an odd number. So what is going to be the predicate? This is going to be the predicate. This predicate becomes an argument to partitioning by. And this partitioning by will be used in the collectors in the terminal operator collect. And at the end, what you will be getting out of this collect because of this partitioning by is a map of boolean and the list of integers. And this map will contain only two values. Two keys, that is true and false. And the values will be the list of integers who are either odd or even. And hence you partition the whole input into two parts. Based on the predicate, either they are even or they are odd. So what is going to be the return type of this particular?
The return type of this particular collectors will be either true or false. The true will contain all the elements that satisfies the predicate. False will contain all the elements which does not satisfy the predicate. And the predicate is percentile by 2 equals to 0. So true will be those who are even and false will be those who are odd. So if this is clear, now let's see the real-time use case of this partitioning by in the e-commerce website. So suppose I have an e-commerce website and I have to find out the customers whose spending exceeds the threshold. For example, who has purchased from my particular website or the e-commerce holding more than of $10,000. They becomes my high value customers because they are paying more to me and they becomes the VIP customers to me. And the false group will be the regular customers whose spending is less than $10,000. So I have the customer list with me. I'm going to stream on them. I'm going to collect them. But while collecting, I want two groups of my customers. Who are my VIP customers and who are my regular customers. So I'm giving the predicate whose total spendings is greater than $10,000. If that is the case, it becomes true. Then my true will have all the customers who are my VIP customers. And false will have all the customers whose spending is less than 10,000 and becomes the regular customer to me.
Hey guys, recently we have launched a course covering an end-to-end full stack application using Angular as front end and microservices and Spring Boot as the back end. Also, we have used cloud to deploy this application and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is REST, RESTful web services, Spring Boot and microservices for backend, Angular for frontend. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka Server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So, this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline, and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links. The second is the counting method. So counting method of Java streams is a collector that counts the total number of elements in the stream. It is usually used in conjunctions with other collectors like aggregation. Now I'll give you a very simple example of counting used with collector as in the collect method as an argument for the terminal operation. So I have a list of fruits like apple, cherry and banana. I have to find how many fruits do I have in total. So here I can see I have 3 fruits in my list. That is apple, banana and cherry. So now how will I count that? The way is open a stream on the list of fruits, collect all of them using the counting method, and that will return you a long value of count, and the output should be 3 because I have 3 total apples. So it's going to count everything that I have in my stream. Now how will I use it in real time? Okay. So I have some orders in place. Okay. And I have fetched all those orders in the list for this particular month. So for this month, September, I have total of 15 orders in my list. So this order list contains 15 orders. Now I'm going to stream over them and I'm going to collect them. And during collecting, I want to count them. So during counting, I'm going to fetch the total orders in the long precision. So this is how I can fetch that for this month of September, I have total order of 15. So from the list, I can count how many elements are there in the stream. Now this is very useful to generating daily, weekly and monthly sales report to measure the business performance. Now third is summarizing int. Now this is very important method if you're working with numbers or the integers. So summarizing int is a method of stream which is a collector. So this is again going to be used in the collect as an argument with the collectors and as a terminal operator. It generates the summary statistics for the elements of the stream. Too much of theory. Let's first see the example of it. So I have given a list. I've been given a list of 1, 2, 3, 4, 5. Now I have to calculate count. I have to calculate sum. I have to calculate min, average and max. What would I have done? I have opened a stream. Then I would have first calculated sum of all. Then I would calculated the minimum of all by putting in a logic that minimum equals to 1. Then go on and search, is there any minimum in the list? If yes, replace my minimum with that. Similarly, I would have taken the first one as max. We'll see. Is 2 greater than max? Yes. Then now new max becomes 2. And all this logic I have to put just to find minimum, count, maximum and all those things. For average, I would have calculated the sum divided with the count and then I would have fetched the average. I have to write 5 different logics for calculating these 5 different operations. So what Java 8 people did for you is that, chalo, we will give you some summary statistics. You just use that over your numbers and you can directly fetch all these things from an object of int summary statistics. So if you can see in the code, if you have the numbers list, then summarizing int is one of the operation here who will return you the int summary statistics object. And this object has count, sum, min, max, and then average would have been automatically getting calculated. So here if you can find about the stats, you can see you have get max, get min, get average, get count, get sum, and so on. So these are the things you can directly get from this particular object of type int summary statistics. So int summary statistics is the return type of this summarizing int method, which is the part of collectors in the collect terminal operation. And using that stats, if you just directly print that stat also, you can see all those stats. Also, not just by printing, you can also do stats.get, and during the get operation, you can get all these 5 operations and you can print them out. So whenever you have the list of some integers, you can always perform all such operations in one single line using the Java 8 operation. The fourth one is mapping. The mapping is used to apply a mapping function to elements of string and then collect the result using the collector. Too much of theory, let's understand the code first. So if I give you an example that you have been given a list of strings or the fruits, you have to collect them and give me not just the name of the fruit, but you have to give me the length of those strings. So if I have apple, banana and cherry, what I want in return is the number of alphabets in apple, that is 5, number of alphabets in banana, that is 6, number of alphabets in cherry, that is 6. So extract and collect the length of all the strings in a list of string. So how would mapping help us? So mapping is the way to apply a mapping function to each element and then collect into the result. So what I'm going to have is the list of strings. I'm going to open a string, and during collecting, I'm going to map each and every of this element to its length. And then at the end, as a terminal operation, collect them to the list also. So if you can see, this is the list of. And what is the list of? List of length of each string you have in the string. So that is the result of the list of strings we have here. And that is why it says that mapping is used to apply a function. What is the function? Get length on each element of the string and then collect it using another collector. Here we have used collector.toList. So the output is also collected in a particular collection. Now let's see the real-time use case of this. Okay. So if you have to extract the email address of employees from the list of orders so that you can send the marketing updates or the order status update to them. So how will you do that? So what you have is list of orders. Okay. From the list of orders, you have to fetch this. So you have the list of orders. What you have to do is to open a stream on them, and while collecting all these orders, I don't want orders as an output. I want the orders having the customers having an email ID. So I want to have all those email IDs who have placed an order with me. So if I have 15 orders for the month of September, I would have 15 customers. Maybe repeating, may not be repeating. And all those customers would have some email ID attached. So I want that email ID also. So I could have opened the stream on the list of orders I have, and during collecting, I will not collect the whole order object. Rather, I will fetch the customer who has placed that particular order, will fetch the email ID of that customer, and then will collect them to the list. So I would have, if I have 15 orders, I might have 9 customers placing those 15 orders. But the output will have total of 15 consumers who have placed the order because we have a list. If you want to find the unique email addresses of your customers in the order, you could have used collectors.toSet. And here you would receive a set of customer emails will be the unique customers who have placed order with you for this month of September. If that is clear, going forward for the joining with delimiters, prefix and suffix. Now this is a very important method of collectors. So before getting into the theory, let's first understand the practical implementation. So you have to concatenate all these strings into one single string. So what you want is, you have a list of strings, you want as output as a single string. So if you remember, there is something called as joining or concatenating all these into one string. Now, during joining or concatenating, you not just want to have some delimiters in between like this, but also want to have this starting and closing square bracket at the start and end. And hence you can use the joining method. If I go here and I put collectors.joining, this joining consists of overloaded methods of no argument, single argument, or 3 arguments. This joining having delimiter, prefix and suffix is used to return a collector that concatenates the input on which it is working. So on what we are working? We are working on words key string, that is the list of fruits. And during collection, I'm going to join each and every of my element of the strings list into one single string using a delimiter as comma. So this is the first argument. This is the second argument. This is the third argument. The first argument is the delimiter. So my apple, banana and cherry will be converted into one single string which is delimited by this comma. And the prefix, this will be appended at the start and suffix will be ended here. And this is how you can use joining with a delimiter, prefix and suffix. Also you have more variations to this joining by with a simple delimiter, no prefix, no suffix, or a simple one with no particular argument given. And this is how you simplify the concat operation. Now going forward with grouping by with downstream collectors. So grouping by is a method used in streams to group the elements by a classifier and also apply a downstream collector to the result. Too much of theory, it's not understandable. Let's understand the practical implementation first. So if I have given you a list of fruits as a list of string, you need to find their length and count the number of string in each group and collect them by their length. For example, apple has a length of 5. Banana has a length of 6, cherry has a length of 6, date has a length of 4. So I want to group them by the size of the string. So I want to group them with 4, 5 and 6. The length of 4 is date, the length of 5 is apple, the length of 6 with 6 is banana and cherry. So I want to group them by their length and not just group them by their length but also count the number of strings in each group. So I have apple as 1, whose length is 5, date is length of 4 as 1, banana and cherry length of 6 and their total of 2. So here I am going to also reuse one of my method, that is counting, that we have used earlier, that is used to count the total number of elements in that particular group of length. So this is how you use the group by to classify your elements based on some function and collect them using counting. And the return type of this is going to be the map, a map of classifier, that is the length, and the value is going to be the number of elements lying in that particular group. The second is the long is the number of elements lying in that particular group when the function is applied. Now let's see the real-time use case of this. So grouping by can be used to group the orders by customers and then count how many orders each customer has placed using the counting as the downstream collector. So you can see we have used two collectors. During this collectors, I am grouping by, and here at the end I'm going to collect them actually in real. So I have, suppose for this month of September, I have received 15 orders that are given by 9 different customers. So one customer can have repeatedly given all the 3 or 4 unique orders, or they might be given by 3 or 4 different customers, and hence I want to find out how many customers have given me how many orders. So this is how I can open the stream on the orders list I have, that is 15 orders I have. Then while collecting, I'm going to group them, and group them means create a map of them, where the key is going to be my customer and value is going to be the number of orders they have placed, and hence the second argument is the collector, which is going to count the total number of orders that particular customer has given to us. So that's key and the value. So this is used to generate the report on how many orders each customer has placed, which is used for understanding the customer loyalty, identifying frequent buyers and tailor marketing efforts. So this is very useful in the real-time scenarios of e-commerce website. Next comes filtering. Now this filtering is different from the filter operation we have seen earlier. Okay. Filtering is used to filter the elements and then collect the result using another collector. What you would have done in the previous filter is you have given the list of numbers, you filter it then and there and apply filters on each and every of them. While the filtering does not apply as an intermediate operator, it works in the terminal operator, and that is going to work on the last operation, as the last operation, all the operations when you have already done on your screen. Now suppose I want to filter out only the even numbers. So while collecting, I am going to find out all the even numbers and collect them to list. So this is simple, right? All the even numbers will be filtered out. But now, firstly, I have to map them into 2 and then filter them out. So I would have applied all the intermediate operations like mapping, distinct, sorting, everything I would have done. And then at the end, I would have filtered out using the collectors.filtering in the collect method, and then at the end collect to the list. So this is how you can filter the elements at the end and not at the start. When at the end you have only those stream of objects which are actually useful, on that if you want to apply some filtering, then you can do it in the terminal operation. Now suppose you have an e-commerce website. Now you want to fetch all the orders who are very high value orders for you, that is whose value is greater than $500. So you can do is to open a stream on the list of orders for this September. So 15 orders you have. Then while collecting, you need to filter out only those orders whose amount is greater than 500. So only those orders you want to find where you have very high value orders, like whose value is greater than $500. Collect it to list. And this helps you generate the report of really high value orders for the special customer attention, fraud detections and VIP treatments. Now, very important question. What is the difference between the filter and this filtering? So when it is applied, the filter is applied before any terminal operation that is used earlier in the stream, while filtering is the part of downstream collector, that is, it is a part of terminal operation, and it is usually grouped with grouping, mapping and collecting. Now where it acts, the entire stream is where your filter acts, but filtering acts only in the group or the end of your stream, that is the result when every intermediate operation has been applied. The resultant group of streams which have qualified your intermediate operations, only on those the filtering would have been applied, which increases the performance at last. Common use case, filter can be based on some condition before any further processing, you are stopping it. While filtering is to be applied for the group or the downstream collections where everything is done, now filter them out and give it to us. How do you use it? We open a stream, we provide a predicate to this filter and then collect it. While how do we apply the filtering? We open a stream, we do all the intermediate operations, then at the end, while the terminal operation is there for the collect, in that collect, during the group by, we can apply multiple groupings, we can apply multiple partitioning, we can apply multiple mapping, and then filter them out and then collect to the list. So this is to be used in a complex operations and will be usually used in conjunctions with grouping by, mapping and so on. Going forward, collecting and then. Now collecting and then is a collector that first applies a collection operation and then applies another function to the result. So collect them and then do something to it. Theory, let's go to the practical implementation first. So you have a string of fruits, a list of strings. Now you have to get the size of it. But before getting the size of it, you need only the unique fruits in your output. So first of all, when you want only the unique fruits, you will need to have a collections to set. And after you have everything collected to set, then only find the size of it and return the size of it. So I have apple, I have banana, cherry and banana again. So I have 2 repetitions here. So how many of unique are there? Only 3. So first of all, rather than fetching the size, first create the set of it and then find the size of it. So first, what you will do is you will collect them and then you apply a function to it, and that is collectingAndThen. So it is a collector who first applies a collection operation, that is collected to set, and then applies another function, that is now find the size of the resultant set. So what is the return type of it? It is going to return you a collector which first collects the element and then transforms the result. So this collectingAndThen will going to return you a collector which you can use to collect at the end into the size, and size is going to return you an integer. So output will be 3. Now let's see the real-time example. Okay. Now you might want to collect your consumers in a set and then fetch the customer address, email address. So if you remember previously, what we have done is we have fetched all the orders list. From that we have fetched the customers, and from there we get the email addresses. Now if one customer has provided you 2 orders, then you will have 2 email IDs repeated in your list. So then and there what we have decided, either we can have it in set, or what we can have done is in the collection, in the terminal operation only, you would have used the collection to set and then fetch the customer, then fetch the email ID, then collect to the list. So in this way you will get the list of email IDs but not the duplicate ones, because before collecting you have used collectingAndThen. So during the collecting only you have set collected to set first, and then fetch the customer from the order, then fetch the email from the customer, and then collect it to the list. So that is the beauty of collectingAndThen. It says first collect using this and then apply your function. So this is the useful way to remove the duplicate elements by collecting into set and then return the result using the toList method. The 9th is the mapping with downstream collectors. So we have already used mapping there. Here we can use the mapping with a downstream collector also. So mapping is used to apply a function and then collect the result using another collector. So I'll give you one example. You have a list of strings where you have fruits in place. You have to collect the length of all strings and then sum them up. So suppose, for example, I have 5 plus 6 plus 6. So that becomes 17. So what I have to do is, first I have to map each and all of them to their corresponding length. So apple will be now mapped to 5, banana will be mapped to 6, cherry will be mapped to 6. Before collecting, I'm going to sum all the integers I have. So 5 plus 6 plus 6. That becomes 17, and that will be written as int of total length. So that is how your 17 comes into picture. So mapping is first going to map each and every element of your resultant stream into their corresponding mapped length. So that is what map do, right? Map was just going to replace your original element with the new function that you are applying in the first argument. And then at the end, it also says that downstream collector is used to collect the data. So now, since you have mapped each and every of your element to their length, collect them before summing them. So I could have also used some collectors, like just collect them to list. So I would have a list of 5, 6, 6. But here I'm going to not just collect them, but also summarizing them. Now let's come to some real-time example. So you might want to collect all the unique product name from the list of orders. So suppose I have put an order to your website, but I have purchased 5 different products. Now I want to map each order to the list of products I have. So one order can have 5 products, one order can have 2 products. Now once you have it, then map each product to its name and finally collect all of them into set for uniqueness. So basically what you are doing at the end is you are generating the list of unique products that you sold today. So suppose for this month of September, I have sold 15 orders. Those 15 orders have 19 unique items in them. One order have tube light, another order also has tube light, third order also has tube light. But at the output, I just want once that tube light is calculated. So I want a unique product that is ordered in different order list. So first of all, what I'll do is I'll flat map each order with their product. And then during collecting, I'm going to use the mapping part. So mapping is used to map each product with their name. And at the end, collect it using set. If you're collecting using set, you will get the unique product name at the end. So this is how in real time, you can use that mapping to first map it and then collect it. Either in the previous collecting, we have summarized it using integer. You can here now collect it using set. And hence the result is either set or integer as and when how you apply your downstream collector here. The second argument to this mapping is the collector, and depending on the collector will become your return type. The 10th is the toMap operation. The toMap operation in Java converts each element into a map using a key value pair. So the return type is obviously the key value pair, where key is the key, v is the value. Now I have been given a list of strings which are actually fruits. I want to map them as the key as their name of the fruit and value as the length of apple. So I'm going to open the stream. I'm going to collect each and every element, but during collection, I'm going to map to function.identity and their length. So function.identity will actually return you the same element that you have. So this particular map is going to have key as the element that you already have, that is apple. And it is going to put a value as its length, that is value is 5. Now this is a very simple example. Now how will I implement that in a real-time scenario? So suppose I have an orders or list for this September month. I have 15 orders. But now I want to see which order has how much sales made. For example, order 1 with ID as 1 has been made a sale from my platform is $500. Order 2 is of $1,000. Order 3 is of only $3. So if I want a map of key value pair where key is the order ID, value is the total amount that is actually being sold from my system for that particular order, only that particular order, then I can create a map of it. That is key value pair where the order ID and value becomes the total order. And hence the toMap is going to map each and every element into to key and their its particular value. And this can be done in the collection. That is during the terminal operation. Now this is useful for quick retrieval of total number of amount of the specific order by its ID, which can be helpful for order lookup of financial reconciliations. Now 11th is the toConcurrentMap. Now toMap is very similar to toConcurrentMap, but toConcurrentMap is used where we need the thread safety. For example, toMap cannot be used where I need a thread safety. It will not give me the thread safe output. But now I have a situation where multiple thread can come to me and perform multiple operations. Like for example, collecting them and creating this particular apple, banana and cherry output of their size. I want that multiple threads might run upon them, and I am very tense that is this the thread safe solution? If no, then I can use collectors.toConcurrentMap, which will make sure that how the single threaded model will give you the response, the same concurrent map will give you the response. That is a thread safe solution to toMap operation. That means this collection ensures that the resulting map is the thread safe one and can be safely used in the environments where multiple threads are working on your array list. So the return type is going to be the list of string, obviously, because the return type is obviously the concurrent map because you are using toConcurrentMap method. The output is going to be the concurrent map, and this map is the thread safe map for you. 12th one is very important, that is reducing. The reducing method is used to perform reductions on elements using an associative accumulation function. Theory, too much of theory. Now let's come to an example. I have a list of 1, 2, 3, 4, 5 as an integer. At the end, I want to find the sum of it. How would I find? I would have put a logic. Fetch 1, add 2. Then calculate the total of these two, that is 3. Now add 3 to the sum of these two, that is 3 plus 3, 6. The total becomes 6. Now add 4 to 6. That is 10. Now the total of this becomes 10. Now add 5 to it. That becomes 15. So my output for this result should be 15. So what I have done, I have reduced these two elements to the sum of these two elements. And then I have considered this as 3. Now next time I have considered 3 and the second element, that is 3, and calculate the total sum. That becomes 3 plus 3, 6. Now I have reduced these 3 elements to one element, that is 6. Then added the next element, that is 4. And that is how I have kept on reducing from 2 element to 1, from 3 element to 1, from 4 element to 1, from 5 element to 1, and that is to 15. So I opened the stream on the list of numbers. Then I am, during collection, I am reducing each of them by summing them up. The first parameter to this is the first element that has to be taken as consideration. So during the reduction, the first element is 0. The first sum is 0. The second sum is 1. The third sum is 3. The fourth sum is 6, and go on. So this is the first argument taken as the starting value that serves as the initial result and is used as a default when string is empty. So suppose I have given an empty list. Now I'm going to reduce it. I do not have first two elements, right? So in that case, 0 will be the default value if the string is empty. The second is it takes the function to be applied on these two elements. So first operation is applied with 0, 1, 2, then on this, then on this, and so on. And the return type is going to be the sum of it, because you are applying the sum of it. Now how will you use it in real time? So you are going to reduce your total revenue using the list of orders. So for this month of September, I have done 15 orders. I want to find total how much revenue I have sold on my system or the platform. So on this 15 orders list, I've opened a stream. I'm going to map each order to that total amount. So suppose first order is $500, second is $200, third is, and so on. Then during collecting those orders and when they are mapped to total of their amount, so 500, 200, 300, and so on, we're going to reduce with the first sum as 0, the second sum is 0 plus 300, the third sum becomes 300 plus 200, that is 500, then 200. So this is how you keep on reducing using the integer.sum, and at the end you will get the total revenue that you have sold from your system. So this is useful for financial reporting, where you need to calculate a total revenue generated by all the orders that is done for the month of September till date. Now I have many more things to cover, that is flat map, summarizing double, long, group by concurrent, and very important team, and many more things I have to cover. So there are few more operations which are complex and we need to cover them. If you want the third part of this, just let me know in the comment section. I'll create the third part of this also again. Thank you. Also, if you want any changes to this format, also let me know. I'll create the changes to this format also. Thank you.